Okay, so now we're going to do example E. So that's h of j of 2. So j of 2, we've got our 3 with an exponent of x, that's where our 2 is going to go, plus 2. So that means 3 squared, which is going to be 9, plus 2. So our j of 2 is going to be 11. Okay? So j of 2 is 11, so we're going to plug that into h. So we're going to get h of 11 equals 4x minus 5. So we're going to plug that 11 in. So 4 times 11 minus 5. So that'll give us 44 minus 5. So that's going to be our h of j of 2 equals 39. Okay, so for our last example, we have f of g of h of 2. So that's going to be 3 more than we've done. So first thing we're going to do is inside out. So h of 2, that's going to be 4x minus 5, or 2 minus 5. So we're going to get 8 minus 5, which is going to give us h of 2 equals 3. So then we're going to plug that 3 into the g. So g of 3 is 2x in your absolute value. So 2, 3, which is going to be 6. Then we're going to plug in for our last one, f of 6. So you're going to have 3, 6 squared plus 2. So we're going to end up with 3, 6 times 6, which is going to be our 36. So 3 times 36 plus 2. And that's going to give us f of g of h of 2 equals 110. So now we're going to go into the function operations. We have addition and subtraction. So we've got our f plus g of x, which can be our f of x plus f of g. And then you've got your f minus, which is going to be f of x minus f of g. Remember, you can only add or subtract like terms. You have to leave the exponents alone. We're not there yet, okay? So we're going to go through the examples right now. We have find the following. F of x equals 3x plus 8. J of x equals 5x squared plus 4. G of x is 2x minus 12. And h of x is 3x squared plus 5x minus 3. So we've got g plus f plus g of x. So it's going to be 3x plus 8 plus our 2x minus 12. So now we're going to just go into our basic problem solving. So we're going to combine like terms, our 3x and our 2x. They're both additions, so they're going to be 5x. Then we have 8 minus 12x, which is going to give us negative 4. So f plus g of x is going to be 5x minus 4. So now we're going to look at the other side. It's just the opposite. So we're going to have the same numbers. So 3x plus 8 minus your 2x minus 12. So this is where a lot of y'all seem to have the most problems, is dealing with your like terms when you're subtracting. So I do the subtraction here because we're going to distribute that negative 1 in to make sure these terms are all correct. So you're going to have 3x plus 8 minus 2x plus 12, because that negative 1 distributes. So you're going to do like terms. We've got 3x minus 2x, so we'll have just an x. And then we have 8 and 12, so it's going to end up being plus 20. So our f minus g of x equals x plus 20. So those are our first two examples. We're going to be moving on to the next one now. We have our g plus h of x, which can also be read as g of x plus h of x. So our g is 2x minus 12 plus 3x squared plus 5x minus 3. Big difference here. That exponent is its own term. It's its own like term. So it's just going to be by itself. So that means our 3x squared doesn't go with anything. Then you have just your x values. So those are going to be 2x and 5x is going to give us 7x. Then we have our negative 12 and our negative 3, which will give us negative 15. So that's our g of x plus h of x. So now we've got our h of x minus our j of x. So what we're going to do is we're going to have 3x squared plus 5x minus 3 minus 5x squared plus 4. So we're going to distribute that imaginary 1 in there again. So we'll end up with 3x squared plus 5x minus 3 minus 5x squared minus 4. So this time we have the exponents that match. So that's going to be 3 minus 5. So we'll get negative 2x squared plus 5x is by itself. Then we have a negative 3 and a negative 4 to give us negative 7.